Okay, we are in the middle of page 6, properties of triangle congruence. So these reflexive, symmetric, and transitive property are things we've done so far with angles and side lengths, but now we need to show that it's also true for polygons. So a triangle is an example. So the reflexive property, remember, is just like looking in a mirror. So you have the exact same things. So whatever you have is congruent to itself. Basically what that says. The symmetric properties basically means that the order doesn't matter when you say something's congruent to something else. So you'll see that we just switched that around. So ABC was first here, it's last here, DEF and DEF. So the transitive property, it's kind of long, so it goes over to here. ABC is congruent to DEF, and DEF is congruent to JKL. So DEF is in both of those statements. Since both of these things are congruent to DEF, they have to be congruent to each other, which is what that says. Okay, so then our next theorem is the third angle theorem. It says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So the reason is all the angles need to add up to 180. If these two angles, if you subtract them from 180, you'd get angle C. Well, these are the exact same two angles, so if you subtract them from 180, you'll get the same answer for both of those. So this says if A is congruent to D and B is congruent to E, then the third angles are congruent, so then C and F are the same. Okay, so in this next example, we're going to do a fill-in-the-blank proof. We want to prove that the two triangles are congruent. So we need to show that each of the corresponding parts is congruent to a part in the other triangle. So they gave us a bunch of these parts in the given information. So for the first step, this is from the given, we need to fill in the blank. So looking at the given information, AE is here, it's congruent to DC. So we're going to put DC in here. EB is right here, it's congruent to CB, and BA is congruent to BD. Step 2, we're still in the given information, so angle A is congruent to angle D. Okay, step 3, we now have 3 sets of sides that are congruent, so we've got all the sides taken care of. We need to worry about the angles now. So we have one set of angles, we've got to prove the other two sets. Angle ABE, that's this angle right here. I'm going to mark that in the picture. We'll give it 2 arcs. Will be congruent to another angle because vertical angles are congruent. So it's the other one in the bow tie, this angle right there. So I'm going to name that CBD. The CBD. Okay, then angle E, this is the third angle theorem. We have 2 sets of angles that are congruent in these 2 triangles, so their third angles have to be congruent. So angle E, I'm going to put 3 arcs on it. It has to be equal to angle C with 3 arcs. That's the third angle theorem. And then the definition of congruent triangles, we've shown all 3 sets of sides are congruent, all 3 sets of angles are congruent, so the triangles have to be congruent. They did the first part, we need to write down the second part. Triangle ACB. Perfect. Next page. So these are some practice questions. I want you to try number 1 through 4. Pause your video, turn it back on when you're ready to check your answers. So this says Walter sketched the diagram at the right. He claims it shows the 2 polygons are congruent. What information is missing to support his claim? So we're supposed to underline the correct words to complete the sentence. 2 polygons are congruent if they have congruent corresponding angles and sides. We need both the angles and sides to be congruent. Does the diagram show 6 pairs of congruent corresponding sides? It sure does. That's what these tick marks mean. And then does the diagram show 6 pairs of congruent corresponding angles? They look like they're congruent, but they're not marked as congruent. So the answer is no. So what other information is needed to show that the 2 polygons are congruent? We need congruent corresponding angles. Okay, practice some of this on your own.